Hi, in this video, we will be talking about the procedure and computation of Fieldwork 2 in Fundamentals of Surveying, which is taping on the level and uneven ground. The instruments that will be used in this experiment are tape measures, chalks, pins, and plumb lines. The chalks are used to score hard ground, while pins are used to mark spots with soft ground. The plumb lines are used to mark spots from eye height. The procedure of the fieldwork will be divided into two, even and uneven ground. For the even ground, the chief or party first marks 2 points A and B without knowing the actual distance between the 2 points. We then denote point A as the starting point. Both point A and B are hollow blocks as you see in the video. Nextly, we denote a tape man holding the tape measure at point A as a rear tape man, while another tape man holding the zero end of the tape measure as the front tape man. The rear tape man then stands on point A, while the front tape man pulls the zero end until the rear tape man measures 10 meters. The front tape man then proceeds to mark the point where the tape lands. This is then computed as a single pin. Both of the tape man then lift the tape measure simultaneously and both walk closer to point. The rear tape man then aligns the 10 meters mark with the previously marked tape length, while the front tape man pulls the tape measure taut and marks where the zero end lands. Steps 3 to 5 are then repeated while ensuring that they are walking in a straight line to point B. Take note that for every 10 marks, pins done, collect a pebble to denote a single tally. After reaching point B, the tape man then measures the partial length from the closest pin, marking from point B. Measure this length up to the centimeters. Repeat the procedure for the next trial while starting from point B. These procedures are repeated until the number of trials is achieved. Compute the total distance from point A to B by adding the number of tallies, marks, or pins, and partial length. A single tape length is equal to 10 meters and a single mark or pin, while a single tally is equal to 10 tape lengths or 10 marks or pin. The stated steps were then executed to acquire the following data. In each of the 3 trials, the rear tape man gathered a total of 2 pins and 0 tallies. Partial tape lengths of 7.07 meters, 7.08 meters, and 7.05 meters were also acquired in trials number 1, 2, and 3 respectively.
For the taping of uneven ground, the procedures are almost the same with the even ground procedures. The only difference is with the use of a plumb bob. The 10-meter tape length will be carried over an eye-level distance for this experiment, as it will be unsupported by the ground because we will be using a plumb bob. As you can see, the location that we will be measuring is a lawn that has uneven ground. Our point A is a red container and point B is a chair. To start, for the rear tape man to see if the plumb line is aligned to point B, the front tape man must keep his plumb line an arm's length away from his body, as alignment is approved by the rear tape man. The front tape man holding the zero mark pulls the tape taut until it reaches 10 meters and drops the plumb bob on the ground. This will leave a mark guiding the tape man as to where he should place his marking pin. Take note, for every 10-meter tape length that the front man will place his pins, the rear tape man will collect it in the next batch to know its number of pins. This should be repeated until point P is reached. Remember, 1 tally is equal to 10 tape lengths, which also means that 10 pins is equals to 1 tally. It should be noted that the partial length must also be measured in the same manner as the procedure in even ground. The path is measured back and forth in order to accomplish the number of trials.
Overall, the number of pins that the rear tape man collected are all 3 from the 3 trials, which means that the number of tallies will be 0. Because as we have stated earlier, 1 tally is equal to 10 pins. We also get a partial length of 5.06 meters, 5.09 meters, and 5.10 meters. Since we are done collecting data, we will now proceed to calculations.
Fieldwork number 2, taping on level and on uneven ground. Computation of an unknown distance. First, you must understand that the number of tallies is equivalent to the number of pebbles. And then, to get the number of tape lengths, we must add the number of tallies and the number of pins. And after we solve the number of tape length, we can now move on to solve the length of the course, which is equals to the number of tape length multiply by the length of one tape length plus the partial length of the tape. On taping on level ground, in the first trial, line AB, the number of tallies has 0, the number of pins have 2, and have the 7.07 meters partial tape length. In the second trial, line BA, we have a 0 number of tallies, 2 number of pins, and a 7.08 meters partial tape length. In the third and last trial, line AB has a 0 number of tallies, 2 number of pins, and a 7.05 meters partial tape length. First, we compute for the number of tape length, which is equals to 0 is the number of tally plus 2, which is the number of pins. And it will be equals to 2. In the first trial, length of the course AB, we multiply the number of tape length times the length of one tape length, which is equals to 10, plus the partial tape length of the first trial, which is 7.07 meters. And it will be equals to 7.07 meters. In the second trial, line BA, still the same. We multiply the number of tape length, which is 2, times the length of one tape length, which is 10, plus the partial tape length of the trial 2, which is 7.08 meters. And it will be equals to 27.08 meters. And on trial 3, in the last trial, line AB, we multiply the number of tape length, which is 2, times the length of one tape length, which is 10, plus the partial tape length of the trial 3, 7.05, which is equals to 27.05 meters. And for us to get the mean distance, we have to get the sum of the computed distance and divide them by the number of trials, which is 3. And it will be equals to 81.2 over 3 or 27.06 meters. So in this sketch, it shows that this court, this court is the outline or the layout of the area that we use to gather our data.
Now, to get the distance, we have the following equations. The number of tallies is equivalent to the number of pebbles. The number of tape lengths is equal to the number of tallies multiplied by 10 plus the number of pins. And then to get the length of the course AB, we have the number of tape lengths multiplied by the length of one tape length plus the partial length of tape. So now the situation in on the irregular ground, we have the number of tape lengths that is equivalent to 3, and to get this we have the number of tallies that is 0 and the number of pins that is 3. For the trial 1, we have line AB, the number of tallies is 0, the number of pins is 3, the partial tape length in meters is 5.06, and to get the distance or the length of the course, we have for the trial 1, we have the length of the course AB 3 times 10 plus 5.06, which is equivalent to 35.06 meters, as you can see. And for the trial 2, so to get the length of the course BA, we have the 3 times 10 plus 5.09, that is equals to 35.09 meters. And for trial 3, we have the length of the course line AB is equals to 3 times 10 plus 5.10 is equal, and it is equivalent to 35.10 meters. And to get the mean distance, we just have to get the sum of the 3 trials and multiplied it by 3, or the number of trials, and 35.06 plus 35.09 plus 35.10 over 3 is equals to 301 over 12, or 35.0 meters. For the sketch, we use the lawn or the grass area or the grass field as the field for the irregular ground. That is all. Thank you.